Mole. 1 mole is the amount of substance that contain as many particles or entities as there are atoms in exactly 12 grams of carbon 12 isotopes. The mass of carbon atom is this 1.99 into 10 to the power of 23. So when you calculate by using this mass, when you calculate how many numbers of atoms are there, then you will get this Avogadro's number. Okay, so this Avogadro's number you will get. See, all these calculations are there in your textbook. So basically what you have to remember here is 1 mole contain 1 mole contain Avogadro's number of atoms. Okay, and this is your 1 mole. 1 mole contain these many number of atoms, and 1 mole even contains atomic mass or molecular mass. You just find out what is the molecular mass, and that many grams of substance will be present in 1 mole. Okay, you just calculate atomic mass or just find the atomic mass or molecular mass. So how will you calculate molecular mass? Suppose if I have this H2SO4, so what is this molecular mass? Molecular mass is sum of average of all these atomic masses. So hydrogen, how many hydrogens are present? 2 hydrogens are present. So 2 hydrogens means 1 hydrogen atomic mass is 1, so it will become 2. So 2 plus, now sulfur have atomic mass 32. Okay, now 1 oxygen have atomic mass 16, so 4 oxygens will be having 16 into 4, so 16 into 4, that is your 64. Okay, so this will give you 98. So this is your 98. Okay, this 98 is your molecular mass. Okay, and 98 grams of H2SO4 will be present in 1 mole. Okay, or 1 mole is equal to 98 gram is equal to 1 mole. 98 gram is equal to 1 mole. Okay, and this will have Avogadro's number of H2SO4 molecules. This will have Avogadro's number of H2SO4 molecules. Okay, now I have already told you what is molecular weight. Molecular weight is the sum of relative atomic masses of the constituent atoms. So this sum of relative atomic masses we have already seen, and we will see in future what is this relative atomic mass. I'll explain you over there, but here it is just whatever atomic mass is present in your periodic table, it is given as relative atomic mass. Now if molecular mass, if you express in terms of grams, then it is called as gram molecular mass. Now this is the first problem based on whatever I have explained till here. So how many molecules are present in 1 gram of hydrogen? So first thing, 1 mole of H2, 1 mole of H2 will be having how many grams? 2 grams. Correct, because so 1 mole of hydrogen will have how many grams? 2 grams, because we know this molecular mass of hydrogen is 2. So 1 mole of hydrogen will have 2 grams. So how many molecules are present in 1 gram? So 2 grams will have how many molecules? Avogadro's number of molecule. Correct. And Avogadro's, what is the value of Avogadro's number? 6.02 into 10 to the power of 23. Okay, these many number of molecules. So 1 gram will have how much? 1 gram will have some, you just put some value x, or x is equal to 6.02 into 10 to the power of 23 divided by 2. So how much you will get? You will get 3.01 into 10 to the power of 23. So which is your answer? C is your correct answer. Okay, let's move to the next question. So number of atoms in 4.25 grams of ammonia. So first thing what we will do is we will calculate molecular weight of NH3. So what is the molecular weight of NH3? Nitrogen. What is the atomic weight of nitrogen? It is 14. Okay, so 3 into hydrogen. Hydrogen have atomic weight 1. So 3 into hydrogen is equal to 3 into 1 is 3. So what is the total molecular weight? It is 17. So see, you can do usually like how you want to do is, okay, so 17 grams will contain Avogadro's number of NH3 molecules. See here, it is asked to calculate the number of atoms, but here we are calculating for NH3 molecule. This you have to remember. So 4.25 grams will have how much? Just put some value x, and this x is equal to 4.25 into Avogadro's number, to x is equal to 4.25 divided by 17. So if you divide this, what you will get? You will get here 4. So you will get x is equal to Na by 4. So these many numbers of NH3 molecules are present. So these many numbers of NH3 molecules are present, but you don't have to calculate NH3 molecules, you have to calculate number of atoms. So one NH3 molecule will have 4 atoms. One NH3 molecule will have 4 atoms, 1 nitrogen and 3 hydrogens. So these many numbers of ammonia and these many numbers of molecules will have how much? So just Na divided by 4 into 4. So for Na divided by 4, okay, Na divided by 4, you have to multiply it by 4. Why you have to multiply by 4? Because this Na by 4 you have calculated for ammonia molecule, and one ammonia molecule contains 4 atoms. So if you multiply it by 4, you will get number of atoms, because this is number of NH3 molecules. How many NH3 molecules are present? This will give you how many numbers of NH3, but question is about number of atoms. How many numbers of atoms are present? For this, if you just multiply and divide, you will get this Avogadro's number. So which is the nearest answer? This is the nearest and correct answer. Okay, there's another approach to this question. What is that another approach to this question is basically, see this well, molecular mass of ammonia is how much? 17. And see this 4.5, whatever is given, 4.25. So this 4.25 whatever is given is 1/4 of this. If you divide this 17, if you just divide this 17 by 4, you will get 4.25. Okay, so because 16 divided by 4 will give you 4 and 1 divided by 4 will give you 0.25. So this is 17 by 4 will give you this. Similarly, here 17 will have Avogadro's number of molecules. This also is divided by 4. These many number of molecules you will have in 4.25 grams. Now you have to go to number of atoms. So to calculate the number of atoms, this you just multiply it by 4. 4 and 4 get cancelled and you will get Na. And this Na value is, again I am telling you, 6.02 into 10 to the power of 23. Okay, so which is the nearest answer? This is the nearest answer. Okay, so this is the last question what we are going to solve here in this. See, the charge of 1 gram of ammonia. So we will see this formula. I think you all know this formula. First we will calculate the moles. How many moles of aluminum are present? So what is the atomic mass of aluminum? First of all, you should know atomic mass of aluminum. So atomic mass of aluminum is equal to 27. Okay, atomic mass of aluminum is equal to 27. So moles of aluminum. So moles of aluminum in 1 gram is equal to weight divided by this atomic mass. So what is the atomic mass? Weight divided by atomic mass. So weight given is 1 gram divided by atomic mass is 27. So 1 by 27 is your mole. So 1 mole will have Avogadro's number, right? So these many moles, 1 divided by 27, this one you just multiply it by Avogadro's number. Correct. See, if you multiply these many numbers of moles you are getting, I am not converting into decimals. So if you just multiply it by Avogadro's number, you will get how many aluminum are present. This will give you number of aluminum in 1 gram. Okay, now 1 aluminum have 3 plus charge. Okay, 1 aluminum have number of aluminum in 1 gram. Number of aluminum in 1 gram. So now see, 1 aluminum have how much charge? 3 plus charge. Correct. So now this much you have to multiply it by 3. So 1 divided by 27 into 3 into Na. Okay, so this you will get 1 by 9 Na. Now even see, answers are given in electron coulombs. If they would have asked like how many electrons are lost, then this 1 by 9 Na would be the answer, but answer is given in coulombs, so you just multiply it with electron charge. So what is the electron charge is E coulombs. So this 1 by 9 into Avogadro's number into E coulombs is your answer. So this is your correct answer. See, basically what you have to do is, first you calculate how many moles of aluminum is present. So moles, what is the formula for moles? Weight divided by atomic mass. So weight is given as 1 gram in problem. Atomic mass of aluminum is 27, so 1 by 27 is your moles, these many moles. I'm not converting this fraction into decimals, I'm just using it as it is. So 1 mole will have Avogadro's number of atoms or molecules. So 1 by 27 will have 1 by 27 into Na, Avogadro's number of aluminum in 1 gram. So now you have to multiply it with how many electrons are lost. 3 electrons are lost. If you just multiply it by 3, you will get 1 by 9 and then multiply it by electron charge. Thanks for watching this. If you have any doubt regarding this, you can ask, or any other concept, I'll just try to make the videos on that. Thanks for watching.